Good morning and hello from my side as well. I'm Martin Reti. I will be a bit more of a guide through this webinar. You also can see our speakers already. They are sitting on the hot seats waiting to provide their content. This will be today on the next slide. You can see them. Additionally, Matthias will start with some strategic insights into the topic of industrial metaverse. Lars from NVIDIA will then take over. And the last one to go will be Thomas from TSystems. So, but first of all, before these three going to talk to you, we will have a short poll and we will ask you for your opinion. I guess now the poll will pop up and asking you two questions. We are very interested in hearing what you have to say about these two questions. The first one would be about your industrial metaverse maturity. How far are you on your journey with that? Are you at the start or already at the end? And the second question will be about the benefits that you would expect for Omniverse or industrial metaverse.
Okay,
So
so
I
I
guess
will
this
first
gives
the
a
first question. I will show you the results. Sorry, Martin, go for it.
yeah, I can see it. We have at least about 60% of you that gave us a feedback, and I think the picture is pretty clear. We see about 42% that are starting their journey with industrial metaverse, but already some of you are at the end of the journey, more or less mature with 11%. So, but I think most of you are at the beginning of the journey, and this is a good idea that you dialed in here to get some more insights how to shape your journey. So now the second question comes up with the biggest benefits that you could see for industrial metaverse. Already, we already have a picture about that. You're still voting a bit, I would say, but it seems that we see the most beneficial use cases in factory planning and operations, which is good because Matthias will talk about that. And the second most important topic would be simulations. I see here. Others are far behind. AI training and collaboration with about 1/3 of you being cases that are targeted or beneficial for you. So thanks a lot for your insights. Maybe we can reflect on that later on once more. But without further ado, I would introduce Matthias to you. He is he has a long journey in IT and automotive. He held several positions in the at the area of IT in automotive with VW Group, Volkswagen, Audi. And I say hola to you because he's been in South America as well. He now covers the part of being more, I would say, a strategic consultant for introducing industrial metaverse, especially in the automotive and manufacturing environment. He's from DreesAndSommer, and they are specialized in utilizing, I would say, industrial metaverse for the whole life cycle of factory planning until up to factory operations. So I keep being quiet. Handing over to you, Matthias. I'm very curious what you have to tell us.
Thanks a lot, Martin, for the introduction. I will try not to talk only about strategic aspects. I will try to send as much useful information what we are observing during our projects that we are doing, mainly in the factory environment. For us, we are using, of course, DreesAndSommer, we are using Industrial Metaverse also internally. So we are using it for our own activities during the planning phase, during the commissioning phase for our customers, and during the support of the operations. But of course, we are also engaging our customers that they should use the industrial metaverse and that they should use Omniverse to leverage the advantages. And I will try to talk about that a little bit. So in a lot of use cases that we are seeing in the market, we are using the industrial metaverse, mainly talking about NVIDIA Omniverse in that environment. We are using it for the factory planning through the different stages, from the very, very early feasibility studies until the start of production, and they're assuring that the factory is doing exactly that what is planned. And then, of course, we are reusing all of these data for the virtual commissioning and the physical commissioning. And I will show you in a minute what are the advantages in doing that. And then, of course, we are using also during factory operations, because we do not have only greenfield approaches, we have a lot of brownfield approaches, so that we are helping our clients, our customers, to change, to adjust the factory while operations. So this is brownfield, and therefore it is a huge advantage if you can simulate and if you can use the already existing data for adjusting the lines, for example, or doing simulations during a brownfield phase. So these are the main three stages where we are using the industrial metaverse, also as a baseline to create the digital twins, and also as a very important baseline for the necessary usage of AI. Petra, may we go to the next slide? Here we see one huge advantage that I want to point out, because the industrial metaverse is able to bring the building planning, the environment, also the infrastructure, with the production planning and with the equipment. So from our point of view, it's very, very important that we are always looking at both sides of the story, that we are looking at the building and the infrastructure that is needed, also the energy flow, and on the other side, the production flow, the material flow, the logistic flow, and the equipment that is needed. And now we are able to bring that together. And what we are doing, what we are offering, is that we are creating a data layer through the three stages to create physical correct environments. And this is the new part. So simulation in a 3D environment, this is nothing new. We are using that since almost 20 years. What is new is that these environments now, these models are physically correct, and they can be used for adding AI-enabled models, and then having a synchronized way of looking at the physical factory and the physical environment and the virtual one. And of course, a lot of our customers also including the product. So these are the three main pillars: the building and the infrastructure, the equipment and the production and the logistic process, and the product. And if you are able to combine this, you have the perfect industrial metaverse, and you are on the way to the factory lifecycle management. And from our point of view, this is what is absolutely necessary to be competitive, that you have your data in your factory environment under control, that you have a factory lifecycle management, not only a product lifecycle management. You need to have your energy flow, your product flow, your part flow. You need to have the equipment completely under control. Please go to the next slide. In various projects, we can observe that this approach that I'm explaining at the moment is creating results, measurable results. So on the one hand, we have cost savings because we have a higher quality level in the data and in the planning process. These can be 10% or even more. Just think about avoiding project supplements. This is in our business. This is what we always try to avoid, that our customers have a lot of project supplements that are rising the costs. With these, if you have these implemented, you can avoid that. And then, of course, start of production is the key. And we are able to shortening the planning period. We are able to shortening in various projects to bring the SOP, the start of production, more early to the market. And then, especially in brownfield environments, you have the possibility to accelerate the necessary re-engineering while producing. So adjusting the lines, adjusting the material flow or the logistic flows, using the industrial metaverse, and Lars will talk about that in a minute also. So these are huge advantages, and we see them even often now in our projects, and we see that a lot of mid-sized company, global players are start using that to ensure the start of production. From our point of view, this is the key message to you. Please go to the next slide. So some typical use cases for you. One of my favorite is supplier integration. So what we are observing is that using industrial metaverse, you are able to work more seamlessly, much more precise with your suppliers. So this can be machine supplier, equipment supplier, doesn't matter. You need to interact during a complex factory project, brownfield, greenfield, doesn't matter. You need to interact with the supplier. Using industrial metaverse, you have these collaboration aspects, and everybody is working with the same scenery, is working with the same data. This is important. Another one is, of course, creating the factory twin. So having the factory life cycle management under control, you have the different digital twins that are combined then to the factory twin. And this is creating a lot of advantages, up to the possibility to start using plug and play scenarios where you can collaborate with your suppliers because they have their machinery, their tooling, their processes, their product already also available as a twin, and you can include that in your digital twin environment of your factory. So these are some typical use cases that we see more often. Please go to the next slide. And then, of course, our recommendation is that you are following a step approach, that you are focusing to use cases that having a business case. So you need to have a business case driven use case. This is customer specific. This is industry specific. Can be more related to the building, can be more related to energy flow, can be related to product or equipment, can be in the production process, can be in the logistic environment. Doesn't matter. It's important that you are deciding for one or two pilots to use cases that fits to your demands, and then create the next step, including more complex environment, including in the next step AI-based, AI-enabled modules, and then having at the end your whole environment, your whole building, your whole factory based in a virtual environment as a replica of the physical environment, and then you are ready to go. Thank you.
Yeah, thank you from my end as well, Matthias. I would encourage our audience to post their questions into the chat, as Petra explained previously. So if you want to have any further insights, post your questions to the chat. But as long as you do, maybe I have a question to you, Matthias. So talking about industrial metaverse, it is said that industrial metaverse is huge. It's expensive. So what's your opinion on that? Is it really only something for huge enterprises that have a lot of budget?
No, if you are following the recommendations that you are start fast, but that you are start with clearly defined use cases, then it is not expensive. It is not necessary that you need to spend a lot of money for equipment or licenses, especially if you are also using pre-configured environments, for example, from TSystems. You can start the journey very, very cheap. So it is not necessary that you think in multi-million dollar expenses to start that journey. You can do that in a very, very economical way, and a lot of our customers are doing it in these steps.
Okay. And then we received a question from the audience. So this is, what is the SOP, so the start of production, for the product development process of a building company, as you do not do serious production in this environment? So this is a bit beyond factory planning, I would say. Can you say something about that?
Well, our projects, if we are planning and realizing a battery plant or a semiconductor plant, or if we are supporting to create a new automotive plant, or helping, for example, Mercedes-Benz actually in several different locations to adjust their factories for the new products. Of course, all of these projects are having one most important goal. This is the start of production. Doesn't matter if this is in the chemical industry, if it's in semiconductor, battery, automotive, aerospace, it's all about start of production. And in a lot of cases, we are helping with the building or with the infrastructure, but in a lot of cases, we're also helping with the production process, with the logistic process. And of course, all of these topics are all focused to assure the start of production. This is the key topic for us and for our customers in the industrial sector.
Okay, so the building companies will be part of the puzzle then, as I understood it correct. There's another question, and this is a down-to-earth question as well that I really appreciate. The original metaverse thing, as you outlined before, hype did not succeed for some specific reasons. Why do you believe that industrial metaverse will not end up as a hype? Secondly, which industrial sector have you seen as a scaled project?
Well, the most important point, because we strongly believe that it will be successful, is that a lot of our customers are already using it, not only in the automotive industry, not only in the logistic industry, but also now battery producers or pharmaceutical, healthcare, environment, life science. These are all customers that are using industrial metaverse, and they are doing it because it has a return on investment. It has a business case, and this is the reason why we strongly believe that it works. Another reason is that we see that the technology that is now available, that the platforms from NVIDIA, for example, that the Omniverse platform is bringing the necessary advantages. So these are the reasons why we strongly believe that this will create value, and this is the reason why the customer and the market are using it.
So you're talking about the maturity of the technology, if I want to summarize that. And this gives us the perfect bridge to Lars, who is already waiting to talk about his part of the puzzle, I would say, of the industrial metaverse puzzle. Lars is EMEA manufacturing partner lead of NVIDIA. He will talk about the technological capabilities of NVIDIA, but he will also talk about one of the most hyped topics in the world at the moment, which is AI and the relation of AI to Omniverse. So Lars, the stage is yours now.
Thank you very much, Martin. So we can already go to the next slide, Peter, from my end. Thank you very much. And this is a perfect segue to what Martin already said and also what came through in Matthias' presentation. So from NVIDIA perspective, first of all, like we said, I want to set a technology foundation. What is Omniverse? That comes in the next slides. But as NVIDIA, or as an NVIDIAN, we always like to talk more about also the future, what enables Omniverse. And this was also one of the questions right now. Why do we think that the industrial metaverse is here to stay? And why do we think it has a huge impact also in the future on the topic of AI? I mean, this call or this webinar is called Shaping the Future with AI and Omniverse. So when we speak about AI, our timeline starts as NVIDIA with 2012. That was when a team of researchers named AlexNet tried out for the first time our GPUs to train deeper neural networks. And with these deeper neural networks, they were suddenly to achieve a 25% improvement in an image contest, which was held every year. In the years before, it was only 1 to 2%. So basically, with the use of GPUs, you could train way deeper neural networks than before. And therefore, this kicked off the first inflection point of AI, which we call perception AI, which is generally called also perception AI. So basically understanding better speech, understanding better images. Second point, I think the audience is really familiar with it now, is the famous ChatGPT moment. So the advantages or the realization of generative AI models. Generative AI models per se are models that can generate text, images, and videos, and also understand these text, images, and videos. Second topic after that, which is now coming really heavily into the market, also on Omniverse, by the way, creating entire landscape is factories with AI, with agents, which Matthias also alluded to in his presentation, and Thomas will also cover this afterwards, is the whole topic about agentic AI. So the main difference between a classical LLM and an agent is an agent can reason. It can use tools and basically fulfill entire processes and help you, for example, designing at least a scratch of the virtual facility by really using an entire workflow on reasoning. And the future where we are looking in as NVIDIA, and this comes handy with Omniverse, is the whole topic of physical AI. Physical AI, the main difference between the classical Gen AI approach on 1D and 2D data, which is text, images, and video, is that physical AI understands physics and therefore 3D world, and also can act in a 3D world appropriately. There's one disadvantage with physical AI, or there's one lack that physical AI currently has, is to train physical AI, you need to implement AI in the physical world. The physical world per se is right now bound to our real time. So basically, you need the real time to train your AI, which is a disadvantage because all the other models which I alluded to were, for example, trained by reinforcement learning, by just using basically speeding up the time and just congestion or just using a lot of data in a really quick time to come to results to deeper neural networks. And the second disadvantage of physical AI or physics is really you have to do it in the real physical world. So for example, like Matthias said, in the real production line, testing AI is not that easy because you have to do it in the real production line. And that's where we come, and please skip to the next slide or go to the next slide, Petra. That's why we come to a platform which we think is one of the foundation layers for physical AI and also for these use cases which Matthias presented in virtual facility integration. The platform is called Omniverse. Omniverse per se is for itself a platform. And that's the important thing. So it's a really capable platform. We call it more like an operating system of leveraging a date or common data, which we call then USD, Universal Scene Description. This is, and Thomas will also talk a little bit more deeper about this from the TSystems perspective. This is highly needed because we see in the industry and overall we have different formats, we have different authoring tools. And for Omniverse per se, it's not there to create anything in Omniverse. It's more of integrating the data and having a data integration into the different authoring tools and the different teams, for example, that design a production line, that design a factory. And therefore, the really crucial aspect is the common format of USD. It's an alliance now. It's called Alliance for Open USD. So there are lots of players which are common in the industry that adopt that format and basically make available to use connectors to then transfer the data into Omniverse from the different authoring tools. So to summarize this slide and then also go to the next slide, Omniverse is a platform which enables a lot of use cases as a physics-based digital twin. So it's all physics-based. Matthias already explained this as well. And the second topic, which is really important, you need a common data format, which is USD. So how does that feel like? And we like to have it as NVIDIA pretty heavy slides. So based from our perspective, from a visualization standpoint, the visualization is always great in the middle. It looks, sorry, just one slide back, if that's possible. Great visualization here. You see it's all physics accurate basically in the middle. So the lighting is perfect. Also the whole simulation of the robots, basically how they behave, how they work is also physically accurate. But the important point is Omniverse has to be understood really as a data aggregation platform and collaboration platform. So the way how it works, there's the visualization piece in the middle, but there's also layers of data that can be added to this visualization or this virtual factory, for example, or this virtual production line, which then enables you to use that data also, for example, for training AI or training agents, or make use of the data that is not even visible in there. You could also integrate, for example, LiDAR sensors in here. So you won't perceive laser per se in a visualization, but they can really use the physics solvers of Omniverse to be trained, for example, on both LiDAR sensors for robots. And now, please to the next slide, Peter. So what kind of use cases does Omniverse therefore enable? If you really understand it as a physics-based digital twin that is able also to train physical AI in the future and even now, there are a couple of use cases. Some of them were already listed by Matthias. I mean, like layout planning, you can really create your factory, your production line in a physics-based digital twin before you even create it in the real world, and therefore really increase efficiency on both, for example, planning, layout planning, also process simulation. Really finding out if the process, for example, these robots really work, if the welding process works, and really simulate things before you really create them in the real world. The obvious example is remote monitoring from a digital twin perspective, as we always see it, but there comes also one caveat to this. If you have the ability to really simulate your remote environment or your physical environment, you can send out people already knowing the failure and fixing the failure beforehand because you have simulated in a digital world. So it's not only the show of data, essentially. There's one easy entry also for Omniverse, which is industrial inspection. So you can also, once you have a physics-based ground truth, you can also create synthetic data, for example, defects on products with Omniverse, and train, for example, AI models to detect then per vision these kind of defects, which have maybe seen only once a month. And there comes the last aspect, and this is more looking also a little bit in the future. It's all about how can you train then physically AI in this physics-based digital twin. Once you have, for example, your production line, you can suddenly use that physics-based production line to train, for example, a robot really on this without sending the robot to the real production line. And you can speed it up, of course. And next slide. Thank you very much, Peter. The last point I wanted to highlight, and just to really get this in the head, because it's more the vision, but also the vision, the highly needed foundation is there with Omniverse, essentially. Physical AI is still, from a left-hand perspective, which we hear on the slide, you have certain inputs like images, videos. The crucial point comes in the middle. A physical AI model needs to understand these input tokens or these videos, images, to make then physical, accurate decisions. An easy example is always around self-driving cars. If you have two barriers in front of you, one is plastic, one is concrete, you want to make sure that you train your physical AI model on the knowledge that if there is no choice, you should hit that plastic barrier and not that concrete barrier. And now comes obvious what I said at the beginning. You don't want to train it with real cars. You would destroy probably a lot of Mercedeses or BMWs. You want to train this in a virtual environment to train your AI in this. And this environment has to be physical accurate. And this is the important point about Omniverse and the technology enabler that also enlightens all these use cases on virtual facility integration, on production line simulation, on really using it. And what also is important, I guess this will also come up in the questions, we see now basically it's really not a difficult task to pull that off. We have all the connectors in place with the most important partners. Thomas will also talk about this. And it's really, you start at the beginning, and then you basically, from there on, you create your own industrial metaverse. And already the beginning use cases have a lot of benefits in there. And that should be it from my side, from the technology foundation.
So thanks a lot, Lars, for that. I don't see any questions at the moment, but maybe some will come up. So question from my end, you were elaborating a lot about AI. We were talking about industrial metaverse. So different technologies, would you suggest to start both at one time? It might be more complex, or you might to have AI skills or additionally at hand to run such an Omniverse project, or could one separate these two approaches?
I mean, you could do it both at the same time, but I would highly recommend to separate. I get a lot of questions with customers and also with partners. What should we do once, for example, humanoid robots are able to fulfill certain tasks in our production lines? And I think the best thing you can do right now, and Matthias also said, is, I mean, if it comes in the future, we all not know when it will come exactly. Is it 2 years, 5 years, 10 years ahead when humanoid robots can really help us in the production line? But what's sure is you should have a physics-based digital twin of your production line to then be able to train your robots in the future on the line. So honestly, my suggestion is start early, especially on the physics side of things. So with the industrial metaverse, because once AI gets more capable, and we see this, I mean, AI got way more capable just alone in the last 3 years, basically. I think then you're ready to set up. That would be my suggestion and my answer.
Okay. Okay, thanks a lot for that. So we will have the opportunity to have some questions at the end of the presentations as well. So if somebody comes up with another question, we will be able to answer that, hopefully. It depends on Thomas now, as long as he is doing his presentation. So Thomas is the executive sponsor from TSystems side for the NVIDIA partnership. And he is now talking about I would say the complete bundle into the industrial metaverse, omniverse world from a cloud perspective, or you can put it as ever you want. Thomas will be more precise on that. Thomas, is up to you.
Yeah, thanks, Martin, and thanks for raising the bar of the expectation for me. Yeah. So if there are no questions, I've done a great job. If there are many questions, that's also a positive sign. But we'll see how it comes out, right? So thanks to Matthias, thanks to Lars. I mean, I have been saying this for the last 1.5 years that virtuality is nothing without reality in the end. Yeah. So at some point you need to hit the reality because other than that you cannot show that the effects that you have in mind and that you have simulated are really showing up in the reality. And that has also to do. Realities today are not only the nice shiny virtual worlds, it's also about the legacy systems that these virtual twins and digital twins need to interact with. Yeah, and in one scenario and in one customer situations, we had like 27 systems, legacy systems that we needed to connect to, and that's a reality as well. And therefore, the three things that you see here, the NVIDIA software, as well as the, DreesAndSommer expertise in factory planning and building planning and operation, um, is a very good starting point, but you need to have the glue. You need to have the glue on the IT side as well to say, look, here's my existing environment. Here's my CAD system. Here's my PLM system. I need to connect those to my digital twin of my factory. And that is where TSystems comes into play. That's what we do. Obviously we do use case development with Omniverse as well for our customers, but and that's the main part. We are responsible also for integrating existing systems that are already operated through TSystems or through the customers themselves, so that the simulation is not like a very restricted simulation of the factory itself, but also the things that are around it. Yeah, and that's something that we do also using our Omniverse platform services, and that we are very proud of this partnership together with DreesAndSommer and also with NVIDIA, obviously, because we think we were one of the early movers here to to lift those benefits and show those benefits. All the things need to come together. And with that, we move on to the next slide, and then we show how we do that. Petra, if you go to the next slide. Yeah, so look, on the left-hand side, you see, the different data sources, yeah, of, it's nothing, and that's true for brownfield as well as for greenfield, right? So that's, the things, you see the CAD systems, you see the Siemens Teamcenter there as well. You see a couple of, authoring systems that feed into this digital twin, yeah? And TSystems as being the platform and system integration provider, we have a lot of experience in complex situations. We have a lot of industry history as well in that regard, especially when it comes to automotive and manufacturing industry, and that these are the services that we're providing to DreesAndSommer, but also to end customers that want to do that journey and take that journey by themselves. And so that the interaction and collaboration, for the customer ultimately, is, it's an often used word, but it's, seamless, and they, you don't have to take care of the, I call it, the dirty work in the engine room, in the engine room of IT. Yeah, so that's where we're coming into play, and we do that, for our customers, so that you can focus on the things that show the benefit and start of production. Matthias was taking and making that point quite often. It's all about having less error-prone situations, and have a higher degree of accuracy when it comes to start of production. Yeah, and if we move on to the next slide, there we show also some further services, a little more detail in that. You see the various areas again on the left-hand side that we take care of. We operate, Teamcenter, we operate ARAS, obviously Salesforce is a SaaS service. SAP as being one of our legacy ST systems. We have great experience there. But all those systems are pumping their data also into the engineering and production layer as well, so that you see also the feedback loop already going back from that nice and shiny digital twin, yeah, to make sure that the reality in the legacy systems, is also connected to that, yeah. And I was thinking about this AI question as well that came up, and sometimes the complexities here are really so mind-blowing that using AI also in the system integration side, helps to get faster results. Yeah, and that's something that we do as well on our existing platforms, and we do this together. And you see it as a little arrow at the bottom, with our stage suite, which is our IP, yeah, to speed up that integration part, yeah, so that you can start faster in simulating and faster in also then applying the AI on the other end, yeah, to simulate stuff, yeah. And that's something where we really appreciate the partnership with NVIDIA, as well as with Matthias and DreesAndSommer, that gave us a lot of feedback on what the realities are in the customer situations. And you see it at the bottom, you see the integration. It needs to be synchronized, it needs to be managed in a way. We were talking about the life cycle. So this whole environment also has a life cycle which needs to be managed, because if something breaks down and it's not being managed, then your accuracy will diminish, of your digital twin. And with that said, I have one further slide which we move on to, and I'm really proud of that. Yeah, it's titled "The Best Is Yet to Come," and maybe some of you have heard about that. It's the announcement that NVIDIA and Deutsche Telekom will provide, beginning of 2026, a platform that has been unheard of in Europe. Yeah, and that is about to stand up 10,000s of GPUs in a TSystems Deutsche Telekom data center. The latest and greatest, DGX B200, as well as RTX Pro servers that we provide then in a cloud fashion, to other providers as well, to really bring this up for Europe and help also the digital industry society, if you like, to generate those benefits more easily that we talked about now in this presentation that much. And we will include also a link to this into the show notes, so that you can link to it and get more insights on what we're doing there. It's really, I think it's propelling the European manufacturing and AI world to the next level. So what we're doing there, and help also customers like Dreso, but also further end customers in this area to benefit from it, and also have the sovereign aspects being applied to it. Yeah, European solution for European companies, operated by European companies. All right, and with that, I close my presentation, and I think we open up for questions, Martin, or?
Yeah, I guess so. But before I bother you with questions, I give you the opportunity to take a deep breath, because a question arrived for Lars, indeed. And so Lars is now on the hot seat, I would say. So the question is, how long does it take to set up a digital twin model, even for a pilot? And how does one go about starting this journey where the problem statement is not that obvious to most? So first of all, maybe, how long does it take to set up such a digital twin model for a pilot? Yeah?
Comes the beloved answer in our technology world: it depends. It depends what you want to achieve with we have to be fair here. This is also a question, I guess, for Thomas as well. I mean, you guys have done a tremendous job also TSystems setting up these pilots essentially. But from NVIDIA perspective, we give more the recommendation. It's not about the time that it takes. It's more about the team that you really educate on this and bring onto the table. Because what Thomas already mentioned is the most tedious job in this is getting the connectors right and getting the authoring tools integrated with the data integrated into Omniverse. And from there up, you can be really fast. Once you have that achieved, I mean, setting up, once we have a CAD model, for example, of a machine, and you just want to have a digital twin of that machine, and the connector is already there, honestly, and you have people understanding a little bit Omniverse, you can be there in 2 weeks, honestly. I mean, given whatever the benefit is of having that machine, honestly, in Omniverse. So it depends, but really, once you understand the platform, you have the right team there, you can be pretty fast. And Thomas, maybe you can also jump in there.
Yeah, absolutely. And maybe Matthias can also add to it. I mean, he's the expert, in reality then, what it is. But Lars, you're absolutely right. So we have seen, those kind of, I would call them isolated MVP kind of implementations, ranging between 2 and 4 weeks. So you can impress already someone with it. But if you want to then, translate that into something that impresses your audience even further, to show benefits, that obviously takes the time, and then the legacy part comes into play. But maybe Matthias, if you want to add to that, from your experience, how much it takes and how long it takes to stand up such an environment.
I guess we need to look at two different parts. The one is having the necessary data available, create the models, and the other one is to have the necessary IT environment. A lot of customers are starting with a predefined IT environment coming from example from TSystems. That helps a lot, because then you do not need to discuss with your IT department in what kind of hardware and software stacks you need. Just use the predefined packages and then start quickly. And then if you are focusing on 1 or 2 environments, if you are bringing up in the metaverse part of your logistic environment, if you are bringing part of your production environment, talking about 1 or 2 equipments that you are physically correct, bring in the metaverse, you can do that in less than 2 months. So these are the experience that we have. Usually our projects are pilots are between 2 and 4 to 5 months. This is usually what we are doing.
And Lars, I think you're the right one to go to if we consider the second part of the question here. How does one go about starting the journey when the problem statement is not so obvious to most? So first of all, finding, I think, the use cases and the business cases.
Matthias is also good in this, I guess, because he already listed a lot of use cases. I think honestly, from without deflecting, I mean, we are the technology platform provider. This is to be clear. So basically, from our perspective, NVIDIA, honestly, we created that platform also for ourselves. I mean, this was not in my slides, but we started creating Omniverse for ourselves because we have our engineering teams all over the world. So basically, those engineers that design our chips, that design our hardware, are really not only located in our headquarters, but all over the world. And they have to work on different tools and different authoring tools and basically create those chips. And now we're talking about 1-year iterations of the next generation. Thomas just talked about Blackwell. Next year is going to be Vera Rubin. And basically, Omniverse was the platform to really help us to speed up the whole cycle. So I think, honestly, the value will come for itself. It can start with engineering from a problem standpoint, but it also can start with manufacturing, what Matthias showed. The thing is really what we observe is even if you don't have a problem statement at the beginning, which is most of the case should be there, to be honest. I mean, you want to solve something in the digital world, in the industrial metaverse. even though if you start, you get more and more ideas once you start. So I can only highlight really kind of the typical technology sentence: get your fingers dirty, try things out with the platform. It's there. Use partners like TSystems or DreesAndSommer to identify even more use cases. But honestly, the appetite and also the use case come also with just leveraging and using the platform. Because otherwise it's always just some slideware and some nice cases which you see from Mercedes or whatever, but it's also really help just using the platform, understanding how it works, and then also leveraging great partners like DreesAndSommer or TSystems to make it really scale and find the other use cases.
Okay, one message to the audience: this is your unique opportunity to raise more questions, but if you want to have more details, so feel free to post in the chat. But I think we were talking about perspectives a lot now, what is happening, what can happen in the future, especially this physical AI thing. But if you want to get started now, Thomas, what would you see? What are the biggest hurdles to get started with such a project? What is the homework I need to do first? How do I get started besides the consultancy finding the use case?
Yeah. So I mean that's an important part, yeah, to identify the use case, yeah, because from that point you can derive a lot, you know, what it takes in order to, you know, connect it to the real world, IT real world, I mean, as well as, you know, the size of the platform, yeah, that you need. It's a difference if you want to simulate, you know, a smaller room versus you know a whole factory with all the ingredients that you need, and that I think you know is a good starting point, yeah, to identify that. And there we can also help, Martin, yeah, with our friends from the digital side of TSystems. And that's then, you know, another question is, where do I want to have the data sit? Yeah, is it on a private cloud? Is it on a public cloud? Is it on premise? So we as TSystems, we can help in all three. And as I said, in beginning 2026, we can even help with bigger sizes. Yeah, but that's a question that also we need to have an answer. Yeah, where do you want to have it? Is it you know, integrated? Is it not integrated? Is it an MVP? Does it need to be connected? And then you know, we deploy those environments rapidly. Yeah, I would say within 2 to 3 weeks we have everything. Once those preliminary and prerequisites are clear, in which area we want to deploy that. Yeah.
Mhm. Okay, I see another question arrived, and this is touching on a topic that we did not talk about so far. It's a sustainability topic, yeah. So I think it's related to Lars and to Thomas a bit. With all the growth and use of AI and agentic AI, the amount of CPU, the power required to power this technology, vast infrastructures of data centers supporting AI consume substantial amounts of energy and water for cooling, contributing to the environmental strain. How can we ensure we are managing the environmental impact of these AI data centers? And this is a crucial question also for the thing you announced, Thomas.
Yeah, absolutely. And this is something that I would say in our data centers of TSystems, really keeps us busy and awake at night for the last, I would say, 3 years. Yeah, and we have significantly improved that part. So, by 2026, we want to power all of our data centers with renewable energy. Yeah, and we're on good track there. And that also holds then true for the one that we bring to life for the AI factory cloud, yeah, that we have there. Yeah, so and you know it's maybe a little side note, but it's one that really drives the company. All of the executives of Deutsche Telekom have their targets, also to achieve the CO2 reductions. And the data centers of Deutsche Telekom are the biggest lever to achieve that. So it's not like just nice to have anymore. So this is really tied to the achievements of the leadership team. Yeah, and that gives it a complete different spin in the end. Yeah, which I have seen in the last 3 years now. Yeah.
By accident, I know that Telekom is the second largest consumer of energy in Germany, counting for 0.5% of the national energy consumption, power energy consumption.
Yeah.
But I guess maybe,
and there,
yeah.
And there you
Yeah.
see, I mean, yeah, that moves the needle. If Deutsche Telekom can achieve more there, yeah, it moves the needle, and that's what we're committed to. Yeah.
Okay, thanks a lot. So we are rather at the end of this one. So I would recommend, if you need further information and want to get in touch directly with our experts, here you can see their email contacts, and they will be happy to answer you further questions, detailed questions that you maybe not want to share in the public. You will receive the slides afterwards, that's for sure. But if you want to get any further information, non-personal information, we also have a QR code then in the presentation that will be distributed, where you can get this additional information and then maybe broaden your view on the topic. But last but not least, I want to thank you, our speakers, for providing these insights. And furthermore, you as the audience being part of this, raising questions, being interested in the topic. I think the future with the industrial metaverse is far beyond role playing, and AI will give it an additional push. So take care. See you again, and bye-bye. You will receive the recording afterwards to share with your colleagues. Bye then.
Thank you. Bye-bye.
Bye.
All right.
Bye.
Thank you.